Hi, I'm Jonathan. This is the final presentation for the Angel Eye Roadway Guardian. And my goal is to make roadway intersections safer. The overall solution, not all of which is implemented for this project, is to build a middleware platform that then outputs awareness to bicycles, cars, and pedestrians and other road users. I drew this technology map and then chose to focus in the upper right corner, exploring light and sound, use of Arduino and Tessel and projector to find ways to build awareness and mitigate collisions. The idea is that taking a camera feed, we can do object identification, then broadcast through light and sound. This was my first foray into hardware, so I invested a lot of time in learning how things work, like with an Arduino, and then upon recommendation from an instructor, moving toward Tessel. With Tessel, I was able to get a servo working and able to calibrate it, measuring amounts of input, converting that into degrees of output, and building charts like this to show in this case, linear response from the servo. But I wanted to do a 2-axis turret, and so here's the result. This system has, it's powered by a Tessel board and the associated servo board. I managed to get it all wired together into an X-axis servo and then a secondary servo. So now I have horizontal and vertical control of the onboard laser pointer. There's been some conceptual things to work around. What I wanted to do is project onto a screen, so I had to find a way to convert screen coordinates to specific servo commands. I did a lot of calibration. This is some of my conceptual understanding of how it was going to work. So I've created a grid. This will be projected onto a wall. You have the laser pointer go specific movements to try to find the right commands to get the laser to point at a specific part of the grid. This is some of the code associated with that. Using JavaScript, I can push code to the Tessel, controlling each servo independently and giving specific positions for X and Y. Now, one thing, the lower half of this set of code, it shows servo.configure servo X and then 0.025, 0.123. There's a lot of time adjusting this two numbers. Those are pulse width modulation, minimums and maximums. And I found I had to use those to do a lot of dialing in to control the overall range of the servos. The overall range so that it's within bounds for the projector screen. So here's an example of the laser moving way too far to the left, but I started to get it dialed in. Here's an additional piece of code. This is running in Python. What I need to do is, by creating this grid and the calibration associated with it for the servo, then I found that I could use just 4 different measurements of the servo positions for X and Y to be able to interpolate between the 4 corners of the grid so that I can have good enough accuracy of the laser turret. For me, this project was very challenging in unexpected ways. Working with hardware was frustratingly slow. Getting hung up on little things like just trying to get the wires to work and being worried about burning out servos. But I'm very proud of the progress that was made. I managed to control a single servo and also using an Arduino, and then moving up to a 2-axis gimbal system with a laser pointer attached, able to point at specific parts of a projected grid. Future work includes being able to remotely send data, not just from a laptop tethered by USB, but also over Wi-Fi or Bluetooth to the Tessel board, so that then the turret is connected via the internet. This is how I envision the data flowing for that next step. And I'd also like to integrate with an onboard vehicle communication system that's rolling out across American roads, dedicated short-range communications dictionary set. So that's Angel Eye, the roadway guardian that spotlights danger areas using a 2-axis laser system.